Hey everyone, welcome back to the channel. In today's videos we are going to dive into some cool Python code that explore a dataset of electric vehicles using pandas, numpy, matplotlib and c1. Let's break this down step by step. Let's go. If you want to create this type of page graph, then for continue watch the full video and never skip each step is very important. So first upload our CSV data of electric vehicle. So here electric vehicle data and create new Python file. Create a title name. So I give name EV data analysis. So our first work importing libraries. Alright, first up we are importing our data science tool. We have got pandas for handling the data, numpy for any numerical stuff, matplotlib and c1 for plotting charts. So our second step goes to load the data. First of all, I write the code and then I will explain you. Here is our CSV file. So simply I copy and then I will paste. Here we are loading our dataset from a CSV file. This file contains a specification of electric vehicles for the year 2025. We store it in a variable called EV, which stands for data frame. Here we have brand, model, top speed, battery capacity, battery type, numerical type and many more data. Almost 478 data and 12 columns. So our next step goes to basic information about the data sets. Here is EV brand non-unique gives us the count of a different brands. Counts of different brand. Our next code print next code. This next line show us all the columns in our data set, basically the different types of data we have, like range, battery size, brand, model and so on. So here our list of EV columns, brand, model, top speed, all the brand names, so all the column name shows. Yeah, hope you will be understand. Our So now moving to our few questions related to our data analysis project. So our first question is, how big are EV batteries in 2025? So first of all, type the question and then I will explain you. So our first question is, how big are EV batteries in 2025? So we are create the histogram chart. We are using C1 histplot to create a histogram of the columns. Battery capacity kWs, that's the battery sizes in kilowatt hours. So let's write the code. Here is our CSV file and here is our battery capacity. Yes, first I copy and then I will paste. First I complete the code and then explain you. Here firstly we are create histoplot and then we give bins 30, means we are dividing the range into 30 bars, and KDA true. Here is our KDA true. KDA true adds a smooth curve on top, that's the kernel destiny estimate. It so the generally safe of the data, and color will set royal blue. And our next step goes to add titles and labels. So first I will write all right. Now let's give our chart voices a title at the top, so viewers we are look, and other one is x label that tells us the unit, and y-axis label showing how many models into each capacity bins. And now last our plt so means show our chart. How is it look? Hmm? Here is mistake. Here is our bins, here is our chart, so look at it. So the conclusion of how big are EV batteries in 2025. So our last conclusion is the data shows the most 2025 EVs cluster in the 50 to 90. Look at it, 50 50 to 90 is something here, uh, kilowatt range, striking a balance between a cost and range. A luxurious model push up the 120, and will city cars prove you don't always need massive batteries? So here high. Here our second question, how far can EVs really goes? So first of all, write the code and then explain step by step. where the magical happens. We are uploading a scatter plot with Seaborn and it's doing a lot of just in one line. First of all, x battery capacity, that's our x-axis. More battery battery is equal to potentially more range kilometer. Y-axis, y variable range kilometer. Our y-axis showing the driving range in a kilometer, and here the cool part, we color the dots: drivetrain type, FWD, RWD, AWD, and so on. So here is our hue, and here is our color palette various. And now other one, alpha 0.7, it's on the transparency, so overlapping dots don't clutter the view. And other one is S100. So our next step goes to add titles. So let's give our chart some context. We are adding a descriptive title on the top of the table chart, and title means what this chart is all about. And our x-axis is battery capacity and y-axis is range capacity, estimating a driving range. Steps: it's a custom legend. Conclusion: good news for a road tripper, most 70 kilometer. EV now excited 400 kilometer. Here is 70, 60 and 70 kilometers are 600 plus our speed range, with luxurious model hitting a 600 plus kilometer. But here the clutch AWD models sacrifice 10% of range due to extra weight and drivetrain losses. Still day of the range anxieties of the fading fast. Here is luxurious brand denoted by blue. So our third question is, which EVs electric vehicles are speed demons in 2025? So firstly I write the code and then I will explain you. Now this is a sleek move. We group by data, group data by segment. Here is group by the segment by data. Calculate the median top speed of each. Calculate the median of top speed of each. Sort them the slowest to fastest and grab the orders. Why? So our box plot is nearly arranged from the left slowest cars to right fast cars. So our next step goes to draw the box plot. Now we see one powerful box plot. To create the chart on the x-axis, we have the vehicle segment order as we just defined, and on the y-axis we are plotting the top speed kilometer. Here is our top kilometer speed meter, and this shows the full separate medians, quartiles, and any outliers. We are rotating the labels of 45 degrees, so they don't overlap, and aligning them to the right for that clean. Our next step goes to add titles and label. So first of all, we are adding title. What we are looking shows the title works. X label, what categorized of cars we saw, and our Y label is what being measured. Measure part goes from Y label, and then our last plt dot show, which one is show our chart. So see our chart. Top speed segment, mm, mini to luxurious cars segment, and top speed segment goes to 175, and our top notch goes to 325 up. Conclusion is luxurious EV dominate with 250 plus kilometer per hour top speed, but here is the surprise component. SUV has on average 170 kilometer per driving. Even practically EVs can be a quickly manual commercial van. Will they prioritize utility over speed? But that is no soccer. Here is fourth question is, which EVs are the quickest in 2025 or fastest? So first of all, we write the code and then we'll explain you. Give me a second, I will explain you briefly. First of all, I write the code and then I will explain you briefly. Give me a chance. So all right, first of all we are categorize how quickly each EV models can go from 0 to 100 kilometer. We can use pd.cot to bucket them into a speed categorized. Next step goes to creating a pivot table. So first of all create a table and then I will explain you. So we are creating a pivot table to account how cars models fall into each acceleration categorized for every vehicle segment. We are grouping by segment like SUV, uh, hatchback, and summarizing an acceleration category, Excel category. So our next step goes to creating a heat map. C1 heat map to show the count of the models by a segment and acceleration category. We are using color palettes. So here is our C map and here is using color palette. Color palette CBU, blue and purples. So annote means show the actual numbers inside each cell, and FMT forms those number as whole integer. All the values source from a integer. Our next step goes to creating titles and labels. So yeah, where we're applying our titles labels name, and now we'll execute the code. So here is our heat map. So here is our hyper speed range, sport, fast, average, slow less than 20 second. Here is our vehicle segment. All vehicles are available. Conclusion, hyper EVs like the Porsche Taycan Turbo GST. Sorry, yeah. Hyper likes the Porsche Taycan GT. It's 0 to 100 kilometer in a 2.2 second. Here is our 2.2 second. Faster than most supercars, but the real win. Even a mainstream EVs now accelerate in a 5 to 7 second, demoing their gas powered rivals. Instant torque for the win. So here is our fifth question: which EVs pack the biggest punch? So first of all, write the code and I will explain. So here is our box plot data from our EV variable file, and drop NA subset of Toki NM and dry and x-axis. Here x segment is drivetrain and y variable is Troco NM. So next we are using titles and labels. So here is our box plot. Here is conclusion. AWD performs EV deliver monster torque Q7 plus 100 mm, but even RWD models now offered from most ICS car. Fun fact: the GMC human EVs are produced with 12 nm, that is truck pulling power is 0 emission package. So here is our last question: who is leading the fast charging in 2025? We have created two charts. First one distribution and second one by the segment. So first one, create our first subplot using his plot. So here we are creating a hist plot using fast charging, being study and KD true. Title is our fast charging power and X level is charging. So our first subplot like this, and now we are creating another chart using by segment. So let's write the code. I can write the name by distribution. And this one by segment. Here we are grouped by a segment with fast charging, median, dividing by median, dot sorted. Our next goes to creating a box plot. Data extract from EV, our CSP. In X we use segment, in Y we use fast charging, and order. Here we are creating a box plot using fast charging segment. We are import xtix label, so simply plt.xtix. Here we have the x label. Now plt dot tight layout, and then plt dot sorry, one thing mistake here. Where is series is not attribute. Here sort values, I forget that. Now here our second box plus chart, which one is top charging power velocity. This one is luxurious car win. Bigger car less is equal to efficient cost. Size matter or sadness and hatches are the efficiency of the king. Will large SUV guzzle 200 plus will, but here is the twisted some streams SUV like the Tesla Model Y. Tesla Model Y revolves sadness of programming radius are just as a key or size. We have the 2025 EV market is a bigger, faster, and more diverse than ever. Which start shocked you the most? Let me know in the comments, and don't forget like and subscribe for data driven car insight. Next up we are analyzing EV prices versus performance. Are you getting what pay for? See you in the next video.